Hi, my name's Robin Moffat. I'm a developer advocate at Confluent, and today I want to tell you about a project I built using streams of live information about train movements around the network and how I can process that using Confluent and Apache Kafka to build some pretty cool things. So as a developer advocate in the before times, I would hop on trains and hop on planes, and I'd kind of do this kind of thing. I'd go around and build demos that were kind of like hello world examples of the technology that I worked with. And this is a great way to teach people how to go and use something from the concepts up, but it doesn't necessarily kind of build out the end-to-end thing that people always sometimes want to see to actually prove that a technology does what you say it does. So one of these days I was at my local train station. I was thinking, well, what other ideas are there for sources of data to actually build something proper? Before I was a developer advocate, I was a consultant at a different company, and I was building data warehouses. I guess nowadays I'd have been called a data engineer. And so I like the idea of being able to take a stream of data and actually pull it into kind of like the uses of analytics and so on that I did previously, and apply the same kind of techniques around data modeling and stuff like that. So sat on the train platform as one does at the early hours of the day to get somewhere, I figured, well, actually, using information about trains themselves could be really, really interesting. And as it happens, one of the companies in the UK here that's responsible for our train infrastructures, Network Rail, it publishes a stream of information about trains. It's published underneath the open government license, which is great. So there's information about the train movements themselves, and there's reference data, and there's all sorts of good stuff like that. So I want to show you today the kind of things that you can build out using this data, and I'm going to walk you through what I've built. It kind of looks like this. We've got data coming in from different places, primarily the information about the trains moving around the network, but also reference data and information about the locations and like geocodes and stuff like that I found in other places. And we pull that into Kafka, we process it using something called ksqlDB, and then we can use it in lots of different places. We can build out analytical views of the data, we can build out real-time dashboards, we can even start to drive alerting based on conditions in the data that we see. As I said, I used to be a data warehouse engineer, data engineer, and so my programming isn't kind of like necessarily my forte, but give me a bit of SQL, give me a few configuration files, and we can build some pretty cool things. And what I'm going to show you here is actually just built without any code, unless you count SQL as code, because it's just configuration, SQL, and configuration to get the data in and transform it and go and put it down in other places. The kind of things you can do with it are building these like analytical dashboards and stuff like that, and that's what I want to show you now to start with. So what we've got here is a Kibana dashboard built on top of this live stream of data that we've got flowing into Elasticsearch. You can see on the right hand side that we've got information about the trains plotted onto a map, and we can kind of see the different, you've got areas and the tracks connecting between them. If you compare it to the underlay underneath, showing the actual train tracks, you'll see it's just drawing direct points between the reported movements on the network. So it's not like a real-time GPS feed of the train, just connecting the dots between the different reported positions. And we can see the reported positions on the top left here, where you've got kind of the station at which it arrived, and was it early or late, the operating company, and then you can see the frequency of the trains within this. So you can see as over the course of the morning they build up in frequency, and as we get onto the evening they'll start to tail off again. But you can actually start to drill into it and analyze it like this. So you can say up here we've got this particular area, and we could click on a particular track and say, well, I'm interested in this particular train, so we'll filter on that one there, and it tells us, if we can zoom into that, actually it shows us the different reporting points on the network. So you can see here the train arrived at this particular time on time, which was nice. And you can see here we're plotting onto it the actual details of that train. What we can also do is you say, well, I'm interested in trains arriving or that are destined for this particular place. So we'll change that, and now we're going to see all of the trains overlaid onto it. You can see the frequency with which the particular trains run. So you can see they run here and then here. And if we zoom out on that, you can see the routes that they usually take. So you've got two different train routes here, one coming out through that and one coming from here. But if we zoom out in time a little bit and say, actually show me the data from the last week or so, we've only got like the last 4 days or so, but you can see actually sometimes we get trains coming from over here, which isn't one of the routes that I was aware of. So let's click on that, and we can see over here we've got 3 different trains. It's all the same, different train ID, but let's click on that one. And now we'll see for just that particular route, you can see, well, it started here and then it went through here, And we can see here, if we look at the time, it was at 6 o'clock in the morning, and it came from this place called Skipton Road CS. So I think, and I'm not an expert on this kind of thing, I think that's a train starting its day, having come out of the sidings, or kind of like where they sleep overnight, it's like Thomas the Tank Engine and so on, but that bringing itself onto the main network. So by having this data and being able to drill into it with the maps, it's really, really cool for analysing how it behaves. Let's see a few other things you can do with the data once it's in Elasticsearch. We can also do some kind of ad hoc analytics. So because actually I'm interested in analysing the data broken down by train operating company. So we'll put that on there. And also I'd like to look at the timetable variation, so like whether it was late or not. So you can put that on there, and we can say the vertical axis is going to be that one. And then we can also break it down over time, like that, which is going to be based on that. So now we can look at, based on train operating company, what was the median delay. So you can see some patterns start to emerge there, and you can start to break it down like this, or put it into a line chart, and look at it in different kind of ways. So that's with the data in Elasticsearch. We can do some pretty nice things. But let's now have a little peek under the covers at what's actually driving that. And I'm going to walk through all about how we built it in a moment, but I just want to show you some of the salient points. We're using ksqlDB with a set of pipelines to actually enrich all of this different data. So we've got the view of it through Confluent here. Within the editor, you can actually run queries, which are going to say, like we can say select star from train movements, emit changes, and that's going to start running now, and that's going to show us a live stream of information from that source topic. So you can see you've got these things arriving here. If we scroll across, you can see things like the station at which it's arriving, the train ID, whether it was late or not. So you can actually now start to build up a picture of the data as it's flowing through the system. You've got all the different topics available to you and information about them, as well as the connectors. So we've got data from within Kafka that we're pushing across into Elasticsearch using a managed connector. And you can click on that and see the kind of status and the throughput of the messages that we're getting. But let's now actually take a step back and have a peer under the covers of how actually we go and build this thing. To start off with, we want to get the data in. We're going to follow the kind of standard streaming ETL concept, so extract and transform and load. But of course, this isn't batch, this is streaming. So we're going to get our streams of data in to start with. We've got data that's coming from the actual network rail itself, which comes from an ActiveMQ point. We've got static reference information, like reasons why things are cancelled, and like lookup codes and where certain places are on the map. And then we've got data which updates like once a day, information about the train schedules and things like that. But this data is coming from different places. We're going to store it all in Confluent, so I'm using Confluent Cloud for this. So we spin through, we create ourselves a cluster. Once we provision the cluster, we go and get ourselves an API key that we can use to actually connect to the brokers that we've created. To start off with, and we're going to see how we can get that movement data in. So as I say, this is sat on an ActiveMQ set of topics, and we can stream that data into Kafka. We're going to stream it in using Kafka Connect. If you've not heard of Kafka Connect, go and check it out. It's really cool. Kafka Connect it's like the integration API for Apache Kafka. There are lots and lots of different connectors for it, and as a data engineer, you simply plug and play the appropriate connector that you want for the technology with which you want to integrate. We'll see it in action again later on, but here we're going to use it for connecting to ActiveMQ to stream this information out the train movements in. Configuring it is relatively straightforward. We identify the particular connector that we're going to use in the connector class here. This is an extract of the JSON that you can see at the top here. So we're using the ActiveMQ connector, we've got our credentials that we need to specify, and then we say which JMS queue do we want to get the data from, and then which Kafka topic do we want to write it to. So we spin up several of these different connectors connecting to different JMS queues. They all stream through Kafka Connect into the same target Kafka topic because it's the same logical data. So once the data is flowing in, you can use Confluent to look at the flow of that data coming from the different places into the target topic, and you can inspect that topic also to look at those messages as they arrive. Now let's see how we get the schedule data in. So the schedule data, again, is published by Network Rail, and in this case it sits in an S3 bucket. So S3, as it happens, you can actually use a HTTP call to connect to pull the data down. So what I've put together here is a slightly hacky way of getting the data out, but it works surprisingly well. So we're going to pull the data from S3, we're going to unzip it, and we're going to push it into a Kafka topic. So we use curl to pull the data down from the S3 bucket. We pipe it through gunzip, which explodes it out into the flat file itself, and then we pipe it through this excellent tool called Kafka. And Kafka says I will take data from standard in, and it will stream it in to the target topic. You can use Kafka in reverse. You can say point it at this particular topic and pipe it out to standard out to process elsewhere. But here we're using it to produce data into Kafka. We've also got reference data that we need to get in. It's sat in flat files, it's sat on web pages. One of the things I want to do with this data is be able to plot it onto a map. So we need to know where the different locations are. So for that, I found a reference file that someone had shared on this open mailing list that had all of the location codes from the data with their corresponding latitude and longitude. So this is a CSV file. There's a great connector for Kafka Connect that we can use to ingest CSV files into Kafka topics. There are different connectors. This one worked really well for me. It lets you do things like set the key of the messages and pass the schema automatically. So this was really neat. So this then streams the location reference information into another Kafka topic. And then we've got other reference data that literally is sat on a wiki page somewhere. You could probably write, I guess, a Python job to kind of like use Beautiful Soup or to kind of like go through and pass it all out. But for the purposes of proof of concept, that was probably a bit too much yak shaving for one day. So I just took this, copied it into a text editor and split it out into its separate fields, dumped it into a flat file, piped that flat file through Kafka. So sometimes the trick with building systems, well, any system really, but particularly around Kafka, is understanding when to do it properly and when to just take a little shortcut like this. If it's static data, it's not going to change. Those shortcuts will probably save you time. So this is what our ingest looks like. We've got Kafka Connect streaming data in from ActiveMQ. We've got Kafka Connect streaming reference data in from a CSV file. And then we've got Kafka Cat providing the ingestion for other data sources like from S3 and from other flat files that we've got. Now that we've got the data in Kafka, we need to work out how we're going to transform it, because we've got a bunch of raw data sat in a bunch of different topics, and we want to take that data and we want to start to denormalize it and enrich it and transform it. So when it comes to transforming the data, we're going to use something called ksqlDB. Before we do that though, we need to understand what the actual data we're working with is. So this is where I was really glad that I actually built out this project, because it's one thing to say, oh yeah, build things using Kafka. It's like it works, yeah, that's great. But it's another to say, well, I've got this entity relationship diagram, and the movement records that I get from the system, they relate to locations, and there's like a one-to-many relationship, and locations have got schedules, and then there's this thing called activations, and understanding how you need to relate these different things and how you express that in stream processing terms was actually really, really useful to do. Now, the good news, and why you're watching this talk, is that you can totally do this. So it was a useful thing to validate it. But what we do is we use ksqlDB to do our stream processing to enrich and transform this data. So it looks like this. We can use it in the web front end. There's also a command line interface. There's even a REST client as well that you can, we'll talk about a little bit later on. But we can build out our stream processing queries using ksqlDB. And what we're doing is we're expressing what we want to do to the data. It's a declarative language. We say, I'd like to select these fields from this particular place, maybe join them to things over here and write it out to a target topic. And ksqlDB figures out, well, this is how I do that. It's like there's an explain plan you can even go and look at. In the background, it runs as Kafka Streams applications, but as a data engineer, you don't actually really need to know that until you kind of like really get down into the weeds. So to start off with, we're going to look at how we process our movement data, because this is that primary fact data that's arriving in the system. Now, the movement data itself, we get this from ActiveMQ. It comes in, you have one source topic on ActiveMQ per train operating company, and we've got one Kafka topic, which has got all of those different source ActiveMQ topics in it. So all of these different logical records. Now, our first challenge with this real-world example of data is that the data we get from ActiveMQ looks like this. So we've got kind of like the message ID, and it tells us what the message type is. And then if you look down it at the bottom there, you've got like a bunch of escaped JSON. So this is a perfectly valid message from ActiveMQ. But what we've got kind of like conceptually is you've got like an envelope for the data, and then we've got our actual payload, because the information about the train movements themselves are that escaped JSON that you see at the bottom of the screen there. So ActiveMQ has got the message, but it's actually a batch of individual messages within it. So our first challenge is like how on earth do we process this data? And we can process it using ksqlDB. So it looks like this. We say, well, we're going to take our source data and we're going to treat it at first just as like a raw string. And we're going to construct it into a JSON array, and we're going to extract out that particular field. Then we say apply another stream definition on top of that, treating it as JSON this time, and now we start to declare a bit of a schema. So you can see there we're saying message array, it's an array of a struct, and it's got a header and a body. That writes it out to a new topic, which we can then actually declare another stream on top of to say, well, now take that and explode it out into separate messages. So that produces at the end of all of this a new Kafka topic with one message per actual message from the original system that got batched up through ActiveMQ and out into our Kafka topic. Sounds funky, but I promise you it works. Our next challenge is, well, within these individual messages, within this single topic that we've built out, you actually have multiple message types. So we have a batch of messages, and that batch we explode out, and that exploded messages, different message types within them. So this is where we actually need to understand that source data. A train movement is different from a train cancellation, is different from something called a train activation. So now we need to say, well, within that original source stream, we're going to split that out to separate target topics. So we're going to have a topic of movement events, a topic of cancellation events, and a topic of activation events. And we do this using ksqlDB. We say create a stream, select everything from the source where it matches this predicate. So we set up those separate split queries, and these run continuously and route all of the messages from the source out to the separate targets. Now that we've got a separate stream of movements, we can start to process them specifically. So we can say, well, this movement data, we can say, well, as a train arrives at a particular place, we'd like to know where it arrived, because it has a foreign key reference in it out to like the location at which it arrived. So now we can say, well, let's look that up against the separate data that we've got, because we've got these separate Kafka topics, and one of them is our movement information. Another of those Kafka topics holds reference information about those locations. So location ID 43 is a place called Ilkley. Location ID 42 is a place called Menston. So we can write a SQL statement that says, as these messages arrive on that source stream, do a left join out to the location, and if you find a match, use that location name in the target message that we write out to a new enriched stream. So this is the kind of thing you can start to do with your stream processing. You can write your SQL statements, which are fairly standard SQL, like do a join between here and there, to actually enrich and transform your data. Other common things that you want to do when it comes to handling data is perhaps you want to build a composite key, so that you can uniquely identify messages. Or you may want to decode a set of values. One way is to actually do a lookup out to a separate table. Another way, like this, is to actually hard code it in a case statement within the SQL. Now, if those values ever change, it gets a little bit funky because you have to go and rebuild the query, which is kind of like the disadvantage of hard coding things. But if it's literally only over that set of values and they're never going to change, which looking at these ones, they probably won't, then hard coding it is fair enough. We need to think carefully about how we're going to handle our schemas, because we've got all of this lovely raw data arriving and we're enriching it and transforming it, but how are we managing our schemas? How are we declaring our schemas? How are we storing our schemas so that other queries and other systems downstream can take advantage of them? One way of doing it is saying, well, with our source data that's perhaps a lump of JSON, we declare the schema up front. When we register that stream in ksqlDB, we go and declare it's got these different fields of these different types, and we create the schema there, and that's fine. Sometimes though, we don't actually want to do that declaration immediately up front. We perhaps want to defer that. So the first statement you can see on the screen here, it says it's going to create a new stream, and it says the body, we're just going to say it's a varchar. So it's actually a lump of JSON with like a big rich schema within it, but we don't necessarily know what of those fields we want to use. Or in this case here, it's the original source stream, which has got lots of different message types within it. So the schema may actually vary based on message type. So in the first example there, you can say we're saying create stream, and we're saying the header is a struct, and we declare explicitly the schema, the different fields within that struct. The body, we say it's just varchar, because we'll process that later when we get to subsequent streams. So a subsequent stream is the one at the bottom of the screen where we say we're going to create a stream called train cancellations, and we do extract JSON field from that original body, and we pull out the particular JSON fields from it using a JSON path expression to identify them. And then we're actually declaring our schema. You can see we're saying as cancellation timestamp, as cancellation reason code. So there's our actual schema that we're declaring. But how do we persist that schema? It's like pretty time consuming to type it in once, let alone multiple times. So we definitely want to make sure that once we've declared that schema, we're storing it. And this is where the Confluent Schema Registry comes in. We get our source data, perhaps it's already got a rich schema associated with it, but sometimes it doesn't. Sometimes it's like CSV we're dealing with or JSON. So we declare the schema once, and then subsequently when we write the data back into Kafka after a transformation, we serialize it using something like Avro, or we use protobuf, we use JSON schema, and this stores the schema in the schema registry, which means that when we come to read the data out, whether with ksqlDB, whether with Kafka Connect, whether with our own application using the consumer API, the schema is available to us. So this is a really, really important thing to make sure that you do. So once we've done all of that transformation, we end up with this kind of pipeline diagram which shows all of the different transformations that we're doing to the data. So you can daisy chain your transformations, but it lets us actually start off with our raw set of data and transform it and enrich it and end up with a set of topics at the end of it that we can then use to drive other systems. So let's see the kind of things we can do with that data. I showed you earlier on an example of it in action, but let's walk through how we built those and a few other examples of what you can do with that data. So we've got our data coming in. We're using Kafka Connect to get the data in from the primary sources, a bit of Kafka Cat as well to supplement it as well. ksqlDB enables us to do our transformations on the data, and all of these transformations that we're doing, they write back to target Kafka topics, which we can then use once or multiple times in independent consumers. So we can do things like this. We can say we'll use Kafka Connect to push the data to Elasticsearch for a real-time dashboard. We'll use Kafka Connect to push the data to S3, probably the same data, but we want to push it to S3 because another team wants to use it for some kind of like data science-y type stuff. So there's lots of different uses for this data. The integrations I'm going to show you are built using Kafka Connect. Obviously, you could use the consumer API itself as well. So in whatever language you're using, whether C, C++, Go, Python, Java, etc., you can use the appropriate client library for the consumer API and build your own applications around this data. But here I'm using Kafka Connect because it's just JSON files to get data from one place and stream it to another. So we can push data from Kafka to Elasticsearch. We say we're going to use the Elasticsearch sync connector. We identify the topic that we've got. We identify our Elasticsearch endpoint and few other configuration things, and off we go. And from that, we can then push the data in real time to Elasticsearch and build ourselves nice dashboards in Kibana on top of that data. Because we built ourselves the location information into that data when we started enriching it, you can start to actually analyze that data and look at like delays around the rail network and see are there particular hotspots within the network relating to that movement data that we've been processing. We can also take the data from Kafka and push it into a database. Databases are magnificent things and they will always be with us and they serve fantastic uses. So by taking the data from Kafka, which we've enriched and processed, we can now provide that data down to a database. We may have a data science team that say, well, this is great data, we would like to analyze it and do our data sciencey team type stuff, but we'd like that data in Postgres. So we say, not a problem, here's Kafka Connect. We use the JDBC sync connector, we identify the topics that we want to handle, and we push that down to the identified database. From there, our data sciencey team roll up their sleeves and they say, this is great, we can build our analytical queries and we can build out crosstabs and we can maybe analyze based on train operating company, how many trains were late, how many were on time, and break it down and do that kind of analysis like that. But let's just pause here for a moment because depending on what they're doing with the data in the database, we could actually say, well, do you even need that database? Now, let's not get ourselves wrong here. A lot of the time you do need a database. Like I say, they are magnificent things, they do great things. But if we're putting the data into a database to build a query that's then going to serve a fixed purpose, perhaps we could actually satisfy that within ksqlDB. I mean, ksqlDB says DB in the name for a reason, because within ksqlDB you can build basically a materialized view. You can declare an aggregate, which is then stored in state within ksqlDB, which you can then query directly. So if you're actually just wanting to build out a fixed materialized view of breaking down by train operating company, how many were late and on time and so on per day, you could declare that within ksqlDB, and then that's available for you to use directly. But a lot of the time you will also want to put that data into a real database to do your ad hoc analysis on it there. So ksqlDB is definitely not for ad hoc analysis, but we've got like a pre-canned query, then it's pretty good for that. Let's stick with our data science team. They say, well, we're using Postgres, we're also going to try out using S3, and actually we want to evaluate them side by side. So you say, well, that's great, we've got the data, it's in Kafka, we've prepared it, we've enriched it, we use the S3 sync connector, we specify our bucket connection details, and we push the data from the topic into S3. So now we have our files in an S3 bucket, and they can go and do some analysis on that data in S3 using something like Athena. So by having the data in Kafka, by enriching it and transforming it once in Kafka, we can satisfy multiple uses for it. We've got perhaps our original use case of building out that real-time dashboard, but we've got subsequent use cases using the same data. We transform it once and we use it many. Our data science team can say, well, let's put that data into Postgres and S3 and compare them side by side, whether they like to manage side by side, the performance, and so on. Or perhaps they're just separate data science teams, one of whom prefer object stores, one of whom prefer relational databases. We can satisfy all of their data requirements by providing that data from Kafka that we've enriched along the way. Perhaps they're not doing relational analysis. Perhaps they're saying, well, actually, we want to look for patterns in the data and kind of like, we're going to look at the data in a different kind of way. So we say, well, that sounds like maybe like you want to do some kind of graph analysis. So let's again use Kafka Connect, push that data down to a database like Neo4j. And here at the bottom of the screen, you can see the Cypher query that we use to model out that relational data into a set of nodes and vertices which describe that data in graph terms. And now you can start to look at, broken down by a particular train station, which trains were there and which ones kind of like were cancelled for what particular reasons, and look at the same data, but in a different way, but using the most appropriate tool for the job. The last example I want to show you is less about analytics and kind of like querying the data and more building on the concept of real-time events, because trains are moving around the network in real time and we're building a real-time dashboard to analyze that or to kind of like stick it somewhere else to analyze retrospectively. But those real-time events are really, really useful. Perhaps you want to say, well, if a train is late or at a particular station, if trains are late by a certain amount, I'd like to know about it. I'm a consumer, I would like to know at my local train station, are things running late? Or I'm responsible for certain SLAs in the network and I need to know if certain things go over a certain threshold. We can drive these kind of push alerts using Kafka and a few little tools around it. So I actually build out something using that set of data and a separate Kafka topic which holds some alert config. So it says if a train arrives at a particular location over a given threshold, over in a given SLA, then we're going to create a new message onto a new topic and we'll use that to trigger the alerts. So we write ourselves a join statement, but we use an inner join. We say, as the events arrive, do an inner join to this alert config table. So anything which isn't on that table, we'll discard. And we've got a predicate based on that threshold. So if the delay is over the given threshold, then we write a message out to a new target topic. This new target topic is the alerting topic, and we can use Kafka Connect to push that topic out to a REST endpoint. So I'm using Telegram here, which is like it's a messaging tool like WhatsApp and so on, and it's got a nice REST API from which you can trigger alerts. There's other examples. I've done another talk in which I use a Telegram bot written in Go to push data from Kafka out to Telegram using a Go bit of code. But here you can actually use Kafka Connect itself, so literally not writing any code, just fiddling around with a bit of JSON. The last thing to think about in building out this is that it's all very fun to kind of like build out Hello World applications or like throw together a few kind of bits of SQL and stuff like that. But what's it like to actually operate? Well, if you're using Confluent Cloud, then most of it's operated away for you. Even if you choose to use self-managed Confluent, you still have access to the same monitoring and maintenance tools. So we can look at like the throughput that we have through our brokers and different partitions. We can look at the connectors that are running and the status of them and manage them from here. We can also see the flow of the data around the system and kind of the relative volumes flowing between different producers and consumers and topics. We can inspect individual consumers and kind of like, we'll say a particular target system isn't receiving its data. We can say, well, is that particular connector or consumer, is that one lagging behind a little bit? And we can really dig down into that kind of thing. To wrap up then, this is what we've built. It's kind of like Hello World on steroids. It's a proof of concept, but it's using real data and it's got real use. It's taking live information from an ActiveMQ endpoint. It's merging that together with information that we're pulling down from S3 and other flat files. We're transforming it using ksqlDB, and then we're pushing it out to our target systems, different systems depending on the requirements of what we want to do with that data. All of it's built around configuration files and SQL to express those transformations that we want to do. You can go and find all of the code for this on GitHub. I'll make sure I share the links in the notes for this video as well. And go and give it a try out. Go and sign up to Confluent Cloud today. There's various different codes that you can use there. And go and try it out. You've got managed Kafka, you've got managed ksqlDB, you've got managed connectors also. Head over to Confluent Developer to go and learn loads more about Kafka and Confluent. There's tutorials and videos and podcasts and loads more. So with that, thank you very much for your time today. You can always find me on Twitter @armoff if you have any questions about what I've shown today or anything else about Kafka and Confluent.